So another, just this piece you need to remember as part of your calculus. If y is equal to a into x to the power of n, then if you want to calculate dy by dx, that means change in y because there is some change in x happened is nothing but n into a into x to the power of n minus 1. That is what the formula. Okay. Suppose, example, say y equal to 2x cube, then dy by dx is equal to 2 into 3 into x to the power of 3 minus 1. That is 6x square. Okay. This is the formula which you have to remember. Mainly, you may be thinking, where can we use this formula? One is indirectly, not directly. This is nothing but your slope, right? We discussed this yesterday. This is nothing but slope. And at the same time, okay, so suppose y equal to x square. There is a equation something like this, y equal to x square. When you have equation something like this, and when you start giving values to the x, let's say x equal to 1, 2, 3, 4, whatever, and calculate your y, this is 1, this is 4, 9, 16, something like this. And when you plot the picture, when you draw the graph between x and for this y equal to x square, you see your graph, your picture is going to look like this. This is equal to y is equal to x square. Okay, this is my x, this is my y. So for every line, whether it is a curvilinear line or a straight line, you have an equation, and that equation is equal to this. Suppose for this, if I plot various values, the negative dimension, positive, whatever it is, your curve is going to be like this. So that means for excuse me, that means for anything, for example, y is equal to, let's say, minus x square. Okay, when you are looking at the minus x square, the curve probably it may go something like this. Similar for various things, y x is equal to y cube. Okay. If you start plotting the picture something like this, okay, where I'm trying to drive you guys is basically I'm trying to give a direction, something called, there is something called maxima or minima. This is closely connected with your dy by dx. Okay. So you need to remember this. So if you have a curve like this, let's say y is equal to x square. This is the lowest point. This is your lowest point. After, see, there is something called convergence. Okay. So what happens here is the values will go down or go up, whatever it is, but there will be one minima. From that point, again, the behavior of the curve, the behavior of the data point will change, basically. So because it is the lowest point, this is called minima. Maxima can be anything because it is infinite. Maxima can be infinite. So minima is something like you can look at it. How do you get this minima? By doing equating dy by dx equals to 0. When you do this, the value which you will be getting is something called minima. That means your this x and y coordinate that you get out of this solving this equation, you will be getting this minimum value. That means at that point, the particular equation of the line will be carrying the minimum value. That's what it means. If you, for the curve like this, you will have one minima. Suppose there may be a few more curves, something like this. Something like this. Okay. Sometimes you will get the curves like this. That means it has multiple minimas, right? In that, there's something you have. The lowest one is this. This lowest one is called as global minima. That means beyond this curve may not have, it may not go further down. Okay. And these are all called as local minimas. They're called as local minimas. Local minima means it is local to this particular segment of the curve. Similarly, you have maxima, global maxima, local maxima, right? So how do you get this one? Either you can go to the d square y by dx square, which is, you can write it something like d by dx of dy by dx equals to 0. If you solve this kind of equation, you will be getting this value. Okay, so when you go into the machine learning course, okay, we will show you different forms, and we will show you how these global minima, maxima keeps changing it, things like that. So you may be wondering, like, why do I want to know about this one? Okay, so again, in the machine learning, you will be getting something called gradient. Okay, there's a concept called gradient. I don't want to discuss about this. It's something like, just show you a little bit. Suppose you have curve like this. So what you do is, you start from one point here. So from this point, you move to this point, and from this point, you move to this point. From this point, you move to this point. From there, you come to this point. From there, you move to from this point. From where you move to this point. From where you move to this point. From where you move to this, the lowest minima. Okay. So this is one of the techniques. This technique is called gradient. So hence, for the machine learning, okay, because you see so many iterations that happens around. So from a hardware requirement perspective, you need to have a better CPU. High-end machines you require for machine learning programming, because there are too many iterative actions that happens from a calculations perspective. For example, if you are dealing with the big data, imagine how many iterations the system has to go through that. So the computing power require more computing power. Okay, so that is one of the underlying principle, underlying requirement for data science. Okay, and to cut it you here, I'm getting into algebra. In algebra, you don't need to know too many things, but yeah, if you know logarithm, that's good enough. If you know logarithms, that is good enough. There are three formulas which you need to remember. Others you don't need to, even if you don't remember also, doesn't matter. Log b to the base a equals to x, then base to the power of x. That means a to the power of x is equals to b, provided A is greater than 0, B is greater than 0. Okay. In the logistic regression, you will be using these formulas in a big way. Okay. Here, the way you look at it is base. See, in mathematics, there are many concepts which will nullify each other. For example, suppose there is a number, suppose there is a 4. So you want to do x square. 4 square will become how much? 16. To nullify the squaring effect, mathematicians invented square root. So this is square, this is square root. Square root of 16 will become 4. So there are so many such functions in mathematics which will nullify the effect of the other. Intentionally they have identified, mathematicians have identified, because that is the way that is the way different processes happen in the nature. In the mother nature, if the world around you is always cyclic, and it is always merges into something else, and it is in a circle. It's in a cycle. Okay. So mathematics is one thing which is very close to this nature. Anything and everything in this planet can be expressed in terms of mathematics. That is why mathematics is called as king of the subjects. Just that people have to have the brain to understand that process. So Ramanujan, when he died, before he died at the age of 32, so he was given so many equations. Even for black holes, he has given the equations. Even still, tremendous research is going in the industry, in the world, to understand his equation. It took almost 100 years for people to really to come to some kind of one or two equations understanding of what Ramanujan said. Now another one, log. This is called base, guys. Okay, log a to the base a equals to 1. So similarly, when we are talking about this x square, right? So for logarithmics, okay, there is a reverse effect. What is that? Log and exponential. They nullify each other. Okay. So during my childhood days, I never used to bloody understand this log. We used to have a book, logarithm tables book. Go there, pick some value. I know how to take the values and go ahead and do your calculation. Later on, when I even that confusion was there before I started my data science. When I got into the data science and started understanding about how different processes around me can be expressed in the form of mathematics, that's when I realized this kind of a logical relationship between the various functions. Okay. Log b to the power of m, log b to the power of m to the base a is nothing but m into log b to the power to the base a. Okay. Now log a to the power of m to the base a is nothing but m into log a to the base a, which is nothing but m into 1. This becomes 1, which is m. Log a by b to the base x, which is log a to the base x minus log b to the base x. See, base can be anything. So generally in the industry base, there are two widely used bases for log. Okay, one is 10, another one is e. Log a to the base e, which is the reverse of your exponential. Okay, log a to the base 10. It is again 10 instead of e, it is 10 to the power of. So anything base that power of can be converted into your logarithmic. Guys, are you with me? Am I making it clear to you guys? This is important, guys. Otherwise, you don't understand anything about logistic regression. Sixth one. Log AB to the base x is nothing but log a to the base x plus log b to the base x. Logarithm of 1 with respect to any base equals to 0. See here, if from here, suppose if I taken it as log 1 to the base e, okay, if I want to nullify this, what will happen? This I am saying this is 0, right? So if I make it as e to the power of 0, if I take this power to this one, what is e to the power of 0? 1. You get this. That is what the nullifying effect means. You understand? Hope you understand what I'm trying to say. Guys, no textbook will tell you these things. This comes out of your own experience. Please understand this. Log negative with respect to any base, whether it is a positive base or a negative, is not defined. If you look into the logarithmic tables, you will not find any negative values. If logarithms is always gives you the positive values. It is all about positive values because your exponential 0 starts with 1. After that, whatever you give, okay, it will go in a different. Even if you say e to the power of minus 1, this can be written as 1 by e to the power of 1. That means 1 by 1, which is nothing but 1. Okay, but however, logarithm of a negative value cannot be defined. Similarly, logarithm of 0 not defined. You can say e to the power of 0 equal to 1, but if it is not anything to the power of 0, you can specify it. But that is how they don't want to look at it. That is, these two are kind of an exceptions from the logarithmic table perspective. Okay. Now, I just talked about maxima and minima. So when you are saying you have a curve something like this, okay, this curve is called concave curve, and you will also deal with some kind of curve something like this. Sorry, this is what is it? Convex. What is happening? This is convex curve. This is concave curve. Okay. You may be thinking, where do I get into this kind of a curve? So this kind of a curve, basically you deal with your error function. Okay. We will generally, any course in the machine learning talk a lot about this error function. Okay. And that is what the story of the entire uh, machine learning. Machine learning people will keep on jumping up and down, right? This is what this is all about machine. These are all the fundamentals for your machine learning, guys. Any questions before I move on to further? Okay. So now let us look at the machine learning, guys. I will give you the insight into you guys. So from a crisp DM framework, you remember we have done this framework. There are 6 stages in this, right? In that 6 stage, you have, let me write it down. Probably you might have forgot about it. One is the business understanding. Another one is data understanding. Another one is data preparation. Then you will have 3 more steps. This is model building or model development. This is your model evaluation. This is your deployment, model deployment. When it comes to the deployment, this is where you get into your AWS or Azure or whatever. Okay. So in this context, if you look into these 2 dimensions, what is that? This data understanding and data preparation. From here, you will be entering into something called exploratory data analysis. Exploratory data analysis will basically revolves around, again, it jumps around 3 dimensions. What is the first dimension? First dimension is data visualization. This is where people use Excel or Minitab, or most likely in the industry people use Tableau or ClickView. First, what you do, whenever you have received the data, you try to plot the different graphs between the multiple variables and study the data, how the data is behaving. What is that you study in the data? You study about the behavior of the data. When you are studying about the behavior of the data, you will also studying the characterization of the data. This is what you remember. I talked about descriptive analysis. Okay. So in the descriptive analysis, you will be knowing what is the sigma, what is mu, what is blah, blah, blah. We have seen so many 10 parameters. What is the range? What is the interquartile IQR range? All these things we studied about that. This is about the data visualization. After the data visualization, you clean the data. Data cleaning has to be done because data may have many null values or missing values. At the same time, data will be coming in different formats to you with the different dimensions, and there are a lot of mistakes in the data. For example, Hyderabad, people can write it as HYD, or they will write it as full Hyderabad, or they may write it as a Secunderabad, or they may write it as a Paradise, something like that. So you have to clean the data, and then you have to bring the data into some kind of a synchronization where data is ready for your further analysis. Okay. After that, you do your EDA. EDA in the sense, you will be from this clean data, you will be trying to figure out how the data, what is this data is all about. That means you do the standardization of the data. You will find out how many numerical data, how much numeric data is you are having, how much categorical data you are having. And once you have the this data that is available with you, then you have to figure out how do you standardize this particular data, or how do you convert your categorical variable data into the numerical data. So all these things are the part of your EDA. Once this is done, your data is now ready. Your data is now ready for model building. Data now ready, data readiness. Okay. After this step, you come to this dimension. Okay. So this model evaluation, now these two basically deals with your machine learning. This is where your machine learning comes into the picture, right? Any question? Is the clarity building you up? Now where we are heading towards? Wonderful. Okay. Now, having said this, now let us look at what is this model? What is this nonsense? People keep on telling about model. We will keep on talking about. There's some jargon. I'm introducing to the new little jargon which you always hear. Model, learning algorithm, training data, test data, best fit line, okay, training data, test data, best fit line, error, okay, there's something called OLS. We'll look into all these things. Okay, these are all different jargons which you come across the moment you step into the data science. And in the data science, when you step into this something called machine learning. Again, what is this machine learning? These are all the different jargon that you come across when you step into this so-called machine learning, which is a wing of the data science, one of the wing of the data science. Let me give you some picture about it. We talked about this example, right? What is this example? Spam and ham, right? So any good mail or anything that you good mail should get into your ham. Anything which you don't like it or you think that it is a junk mail or whatever should get into the spam. That means you have a system. You have a system. To the system, okay, to the system, information is coming, right? That means information is coming into the system, and system will be deciding some kind of an output to this, which will be segregating this based upon the information. It is segregating that whether the mail is belonging to spam or ham, right? So this is your manual functionality. Manually, this is the manual functionality. Let us assume that a mail will be coming into my system, and my system manually decides whether the particular mail is going to be classified as a ham or a spam. Now I want to automate this system. What is that? Now I want to automate this system. So what I do here is, this is my system. This system, I'm calling this one, I'm calling this as this information, I'm calling this as a data, right? Now, before we continue further, let us look at this human. Any human being learns from experiences, right? Based on our experience, we learn things. Okay, if we touch any hot utensil, we know that it is going to burn your finger, burn your hand. How did you know about this? How did you learn this? Then what you do? Based upon this understanding, you avoid touching any hot utilities or utensils, right? Or if you're trying to utilize, trying to touch this kind of utensil, you will use different methods so that you are safe, right? So from the experiences, you will learn something, and that learning something will be put for use for basically from a survival perspective. That is the nature of a human being. And human being is a living being. That means it has prana. It has brain which process such kind of a this is information, which you call it as intellect, which in Telugu we call it as buddhi. Okay, but if you want the similar kind of a teaching, similar kind of an experience to a non-living entity like a computer, okay, for what? For basically making the things done automatically. Here, because I had my previous burnt experience, or someone told me, or my mom told me that don't touch the hot thing, hot utensil, it is going to burn you. I'm able to keep that information in my mind and put to use whenever it is required. So it happens automatically without my judgmental that is going to happen in my day-to-day life. Similarly, if you want a system should do the same activity, you need to, the way you are learning it, system also has to learn it, right? So from where system will learn? System learns from data. System learns from the data, and what it does is system learns from the data, and it also find out find out what is the output, expected output, because it is not a living thing, right? Human is a living guy, so he may aware of expected output, or he may not aware of the expected output. But when we talk about the system, when we talk about the system has to also will be knowing the output of the input process. Where I'm trying to take you is, there is a jargon called machine learning. That means learning from the data. Teach the machine from the data. I mean, make the machine to learn from the data is your machine learning. Okay. What is that you are teaching to the machine? How are you going to teach the machine? You are going to teach the machine using your learning algorithm. This learning algorithm, what it does is, it takes the input data which is getting into the system. It also considers the output of the data. Now, this means, this is like always says that what is expected out of this particular behavior of the system. This system is nothing but a behavior. Okay. This system is nothing but a behavior. That means it may be going through a series of processes or a single process, but something happens inside. Okay, this learning algorithm, which will automate this particular system, considering your input, considering your output, okay, and the output of this learning algorithm is your model. The output of the learning algorithm is a model. What is this model is going to do? This model is going to replace your system. That means this model once created by the algorithm, okay, this algorithm piece on learning algorithm, your machine learning algorithm, keep on listening to the data is getting passed to this, okay, or data is fed to this model, and this model automate the whole behavior of the system and does its own activity. So that is how you make the system automated. This whole thing put together called as machine learning. Am I clear, my dear friends? Yes or no, my dear friends? Did you get what I'm trying to say? Any questions, my dear friend, before we continue further? Because this concept has to sit into your mind. Otherwise, if you don't have this clarity, you may become a data scientist, but you may not be effective. Okay. Well, Arvind responded. Others? So, what I'm saying is, what is the model? Model is a kind of, in a layman's term, it is simply an expression or a equation or certain arrangement of few variables or concepts. For example, we already discussed about it, right? So 1, 4, 9, 16. If you have series of if you have a series of numbers like this, these are the series of numbers. So what I will be doing is I have a system, my mind, that is my mind. My mind is basically calculating the square value. This is my square of the number, square the number, because my mind knows how to do the squaring part of it. So what it does is it takes each number and generates the output. What is the output? If I take 2 as a number, it generates the output as 4. If I take 3 number, I generate the output of 9. So my machine learning algorithm or my machine learning algorithm, this is my algorithm. It takes my 2, 3, whatever the numbers it has. It also takes the input of what is expected of when I get to what is the value that I will be generating. Okay. So it also takes that information, okay, and generates a model. What is that model? That model is y equal to x square. That means if x value is having, let's say 1, 2, 3, 4, whatever it is, my y values are going to be 1, 4, 9, like this. So when this algorithm is doing that, I don't need my mind to function into this one. So this is completely automated. Now I don't need to focus on this particular perspective. This is the model, my dear friends. Model means the whole process is generalized. I'm using the word generalized. That means the process is expressed in the form of an equation, or the behavior of the, or the character of the system, or the behavior of the system is converted into your equation, which you call it as a model. How it is going to get converted? Using your machine learning algorithms. In the machine learning algorithm, now what we do with the machine learning algorithm? Now our focus should be moving towards the algorithm. So friends, hope you understood what I'm trying to say. Is there any difficulty, my dear friends? Okay. In the algorithm, now let's look at the algorithm. Okay. In the algorithm, how algorithm actually, what are the inputs algorithm is taking? Algorithm is taking my input data, and it also considers what is the desired outcome or desired output, right? So this is data. So what we do is we split the data into two. One is called training data. Another is called test data. Always industry practices 70% of a file will be taken as a training data, 30% of the data file is taken as a test data. This is the thumb rule, guys. This is the standard format which in industry follows. You can always go up to 80-20 or 90-10, whatever it is, but this is in general practice, taken into the practice by the industry. So this, suppose you have a data file. Let's say you have 100 records in the data file. Out of this 100, 70 records are taken into your training data and 30 records considered as a test data. Now what they do, they take this 70 records or 70% of the data and build the algorithm. And they, what is that algorithm logic that you are building inside the algorithm? With this 70% of the data, how the desired outcome will be brought into the picture, or how you will be able to, what will be the 70% data's outcome is. So that whole part which you are teaching here, teaching the algorithm, that is why it is called learning algorithm. That means you are already having an existing data. From the existing data, you are actually building an algorithm. When you build such kind of an algorithm, then that kind of a learning is called supervised learning. What is this? Supervised learning. Sometimes you may not have the data, or you may have the data, or some new data is coming up without any labels. Data will have the labels. Labels are nothing but your columns. You may have the data, or it is something like you don't have any previous data, and you need to work on that data and try to do something out of it. That you call it as unsupervised learning data. Unsupervised learning. Friends, are you with me? Any questions here? I'll just pause for a minute, because this, now we are getting into the actual machine learning definition. Now you got the fundamentals. I'm trying to take you into the definitions. Any questions, guys? Here? Wonderful. So you maybe you should not put a blank face saying that sometimes somebody calls machine learning, sometimes somebody calls supervised learning, unsupervised learning. What is this? Very simple. If you are coming up with a model, if you are deriving a model using an algorithm, where algorithm, possess the previous data or has the existing data, does some kind of analysis on that particular data, it is supervised learning. Okay. In supervised learning, again, there are two types. One is called regression. Another one is called classification. In the regression, you get simple linear regression, you get multiple linear regression. In the classification, very popularly known as logistic regression. Okay. Unsupervised learning, predominantly it is clustering. Okay. So here the difference here is you don't have, remember, here no labels. That means there is no previous notion of the columns. Okay. For example, customer segmentation. See, online portal, people keep on buying the product from online. Okay. So identifying the gender of the person based upon the purchases that they made. So when you're trying to do the classification of your customer base, whether the potential customer, high valued customer, or a low valued customer, or a medium valued customer, that is where you use your clustering. Okay. Classification, see, classification basically means whether this particular patient has a corona or not. So this is yes or no. That means, so the output is a categorical variable. Categorical variable means it's not a numeric variable. It is in the textual form, yes or no kind of a thing, right? Whether my customer is going to default the loan or not, right? That is what it is. Regression basically is the output of the regression. The output of both the regressions is continuous variable. Score of a student in the class, continuous. So what it does, it takes the previous, how the student is performing in the previous examination or previous unit test that happened. Accordingly, they will predict how much this guy is going to score in mathematics in the final examination. Because they know unit test 1, they have seen the quarterly exams, they have seen the unit test 2, they have seen the half-yearly exam, and now with these all 4 examinations, now they know what this guy is scoring in the statistics. Now based on this, he can predict how much is the score that we can expect him in the final examination. That score is a continuous variable. Here, guys, are you with me? Are you understanding what I'm trying to say? Okay. Okay. Now, when it comes to the regression, let's look at this little bit of regression part. Wait. Regression. People, they were really worried about what is this regression. What is this regression? Okay. So regression, before we talk about into the regression, okay. So what we will be looking at is, what happened? Where is my cursor? Okay. Now, this is where your scatter plotter will come into the picture. Scatter plot is very, very important. Suppose you have the data like this. Right? So this is my X, this is my Y. My objective here is basically to build a model. What model? Model for Y. in terms of in terms of x. Okay, when I'm talking about y and x, which is a two-dimensional scenario, in such a situation, when I plot the graph, when I plot the scatter plot between the two x and y, this is how the data points are. Now, if I want to come up with a model, that means if I want to come up with a generic equation, generally, if the equation is equal to y is equal to mx plus c kind of equation, okay, y is equal to mx plus c kind of an equation, okay, then there are various possibilities, right? The line can be, now it is not in the line form. When I plot the graph, it is not in the line form. But I am trying to generalize the behavior of these data points in this equation form. So what is the possibility? The line may go like this. Line may go like this. It may go like this. It may go like this. Or it may be something. Or it may be something. Or it may be something. N number of possibilities are there, right? But the best possible line is probably a line something goes like this. That means this is called best fit line. Why it is best fit line? Now I am trying to find a relationship between x and y. Here x is independent variable, y is dependent variable. Okay, in simple linear regression, what you are trying to do is you are trying to find an approach to model the relationship between your x and y. This regression is an approach to come up with a model that will define the relationship between x and y. That is what the regression is all about. If I have one single independent variable and one dependent variable, I call it a simple linear regression. If I have multiple independent variables and only one dependent variable, I call that as multiple linear regression. Are you with me, my dear friends? So regression, now you know what do you mean by regression. So here I would like to say something and then I'll stop you. So your y variable, which are dependent, your y, and this is your x. Okay. This is called response variable. Y is called response variable, or it is also called as dependent variable, or it is also called as target variable, right? Here x called as predicted variable, or it is called independent variable. This is the terminology different books use, my dear friends. You need to be thorough with this. Or exploratory variable, or it is also called as feature variables. Features, that is simply they use the word features. Or it is also called as regression variable. Okay, friends. Okay. So this is about the fundamentals of your simple linear regression and the multiple linear regression part. Okay. So from here onward, you can with this information you can get into your simple linear regression model building. Now you know what is a model. Now you know the test training data. So what you do is from the 70% of the data that you have collected, you build the algorithm. After building the algorithm, you will be taking the remaining 30% of the data, this 30% of the data, you use this 30% data to test the model, how the system is behaving, how the model is behaving. If the predicted value is coming very close to what is the original value, that means your model is doing good. So this 30% of the test data is always unseen data. What is unseen? Unseen data for the algorithm, because you have used the training data to train the model or to arrive at a model, and that model you are passing a test data which is another segment which you have taken it from the existing data itself. Okay, but this data is not seen by the algorithm. It is completely new. This is how you do the simple linear regression at a very high level, at a very foundation level, in a summary. Okay, am I clear, my dear friends? So that's about it, my dear friends. With that said, I can say I am pretty much given you the necessary fundamentals for you to get into the machine learning. Any questions? Okay. One more thing I wanted to show you, it will be very helpful to you. Are you able to see my screen, my dear friend? Oh, no, 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 no. You may have not seen this. Share.